The universe is vast, beautiful, and utterly unpredictable. But beneath its serene expanse lies a dangerous truth: our existence is constantly balanced on the edge of cosmic chaos. From the silent drift of rogue black holes to the explosive power of gamma-ray bursts, there are forces at work in the cosmos that could reshape our future in the blink of an eye. These aren't just distant, hypothetical threats. They're real, tangible dangers that scientists are actively studying to understand how they might one day impact life as we know it. In this video, we'll explore the most perilous cosmic events that could alter the course of our universe, uncovering their origins, their potential impacts, and the fascinating science that helps us prepare for the unimaginable. By the end, you'll not only gain a deeper appreciation for the fragility of our place in the cosmos, but also a clearer understanding of how humanity is working to navigate these cosmic threats. So let's dive into the mysteries of the universe, where danger and wonder exist side by side. The universe is full of wonders, but few are as chilling as the idea of rogue black holes. These cosmic wanderers are black holes that have been flung out of their galaxies, untethered and free to roam the void of space. Unlike the black holes we typically think of, anchored at the center of galaxies, these rogue entities are unpredictable, drifting silently through the cosmos. Their immense gravitational pull could wreak havoc if one were to cross paths with our solar system. Picture this: a black hole, invisible to the naked eye, enters our neighborhood. Its gravity would distort the delicate balance of planetary orbits, sending planets spiraling out of control. Even from a distance, its tidal forces could tear apart comets, asteroids, and anything else in its way. And the scariest part, we might not see it coming until it's too late. Scientists believe there could be millions of these rogue black holes scattered throughout the Milky Way, each one a potential threat. Their paths are impossible to predict, making them a silent, lurking danger. While the odds of one entering our solar system are slim, the consequences would be catastrophic. It's a reminder that even in the vastness of space, some threats are too close for comfort. Gamma-ray bursts are like the universe's ultimate fireworks show, but with consequences far more terrifying than a few singed eyebrows. These fleeting yet catastrophic events are the most powerful explosions known to science. Capable of releasing more energy in mere seconds than our Sun will emit over its entire 10 billion-year lifespan. To put that into perspective, imagine the energy of 100 billion suns concentrated into a single, blinding flash. That's the scale we're talking about. These bursts originate from some of the most violent events in the cosmos. One common trigger is the collapse of a massive star at the end of its life, collapsing inward and then exploding outward in a supernova so colossal it forms a black hole. Another source is the collision of two neutron stars, the incredibly dense remnants of dead stars, spiraling into each other in a cosmic dance of destruction. In both cases, the result is a pair of ultra-focused beams of gamma radiation, shooting out from the poles of the dying star or the collision site. These beams are so intense that, if pointed in our direction, they could wreak havoc on a planetary scale. The danger lies not just in the burst itself, but in its aftermath. A gamma ray burst within a few thousand light-years of Earth could obliterate our planet's ozone layer, leaving us exposed to the full force of the sun's ultraviolet radiation. Crops would wither, ecosystems would collapse, and life as we know it would face an existential threat. The most unsettling part, we'd have no warning. Gamma-ray bursts travel at the speed of light, meaning we'd only detect them at the same moment they hit us. What makes these events even more unnerving is their unpredictability. Gamma-ray bursts are rare, but they're not confined to the distant past or far-flung corners of the universe. They've been observed in galaxies relatively close to our own, and statistically, there's a small but real chance one could occur within our cosmic neighborhood. While the odds are slim, the stakes are unimaginably high, making gamma-ray bursts one of the most formidable natural threats humanity could ever face. Picture a star millions of times brighter than our Sun, reaching the end of its life in a cataclysmic explosion so powerful it can outshine entire galaxies. This is the fate of a supernova, a cosmic event both mesmerizing and terrifying in its scale. While these stellar explosions are breathtaking to observe from a safe distance, their destructive potential becomes all too real when we consider what might happen if one occurred too close to Earth. The sheer intensity of a supernova releases an onslaught of radiation, capable of stripping away our planet's protective ozone layer and exposing all life to deadly cosmic rays. History offers us glimpses of how supernovas might have already shaped our world. Some scientists believe that a supernova explosion tens of thousands of years ago could have triggered significant climate shifts, altering the course of life on Earth. In more recent times, the remnants of supernovas have left behind radioactive isotopes in ocean sediments and ice cores, serving as silent reminders of their far-reaching influence. But what if a supernova occurred within a few dozen light-years of Earth? The consequences would be catastrophic. Ecosystems would collapse under the barrage of radiation, and mass extinctions could follow. Even more unsettling is the fact that such an event is not a matter of if but when. The universe is vast and stars die all the time, some closer than we might like to think. Yet, it's not just the immediate vicinity of a supernova that matters. Even distant explosions can have subtle but profound effects. For instance, a supernova hundreds of light years away might not destroy life on Earth, but it could still disrupt our atmosphere, trigger climate anomalies, or leave behind a faint but detectable signature in our planet's geological record. The universe is a dynamic, interconnected system, and supernovas are one of its most dramatic reminders of how fragile our existence truly is. While the odds of a nearby supernova occurring in our lifetime are slim, the sheer scale of these events forces us to confront the reality that our planet is not an isolated bubble, immune to the chaos of the cosmos. Instead, we are part of a vast, ever-changing universe, one where the death of a star millions of light years away can ripple through space and time, leaving its mark on our fragile world. While the sun bathes our planet in life-giving light, it also harbors a darker side, one capable of unleashing chaos on a global scale. Solar flares and coronal mass ejections, or CME, are among the most formidable threats our star can produce. These intense bursts of energy and charged particles surge from the sun's surface, traveling through space at staggering speeds. When directed toward Earth, they can interact with our planet's magnetic field, triggering geomagnetic storms that disrupt the delicate systems we depend on every day. Imagine for a moment a massive solar flare erupting from the sun, sending a wave of high-energy particles racing toward Earth. Within hours, satellites could be knocked offline, cutting off communication networks and GPS systems. Power grids stretched thin by the surge of electrical currents might fail, leaving entire regions in the dark. Even astronauts aboard the International Space Station could face life-threatening radiation exposure. The Carrington event of 1859 offers a glimpse of what this might look like. Back then, a powerful CME caused telegraph systems to spark and fail, with some operators even reporting shocks from their equipment. While the technology of that era was primitive compared to today, the event serves as a stark reminder of the sun's destructive potential. Fast forward to the modern era, and the stakes have never been higher. Our reliance on technology has made us far more vulnerable to the sun's outbursts. A single massive solar storm could cripple global infrastructure, plunging us into a technological dark age. Banking systems, transportation networks, and emergency services could all falter, leaving societies scrambling to recover. The economic impact alone could run into trillions of dollars, with recovery taking months or even years. And as we continue to push the boundaries of space exploration, astronauts venturing beyond Earth's protective magnetic field face even greater risks from solar radiation. But here's the twist: while the sun's eruptions are unpredictable, they're not entirely beyond our ability to prepare for. Scientists are working tirelessly to improve our forecasting capabilities, giving us precious hours or even days to brace for impact. Satellites like NASA's Solar Dynamics Observatory keep a constant watch on the sun, monitoring for signs of activity that could spell trouble for Earth. By strengthening our infrastructure, developing resilient technologies, and creating robust emergency plans, we can mitigate the risks posed by these cosmic events. The sun may be a constant in our lives, but its potential for disruption is a reminder of just how interconnected and fragile our modern world truly is. While asteroid impacts might seem like the stuff of science fiction, the reality is that Earth has faced this danger before, and it could happen again. 66 million years ago, a massive asteroid struck near what is now the Yucatan Peninsula, creating the Chicxulub crater and setting off a chain of catastrophic events. The impact unleashed energy equivalent to billions of atomic bombs, triggering wildfires, tsunamis, and a global nuclear winter that blocked sunlight for years. This single event wiped out the dinosaurs and reshaped the course of life on Earth. Today, the threat of a similar impact looms in the background of our existence. While large asteroids are rare, they are not impossible. Even smaller objects, like the one that exploded over Chelyabinsk, Russia, in 2013, can cause significant damage, injuring thousands and shattering windows across an entire region. The difference is scale. A larger asteroid could devastate continents or even the entire planet. Thankfully, scientists are working tirelessly to detect and track near-Earth objects. Programs like NASA's Planetary Defense Coordination Office monitor the skies, cataloging asteroids and comets that could pose a threat. But here's the catch: space is vast, and some objects remain hidden until it's almost too late. Even with advanced technology, an asteroid could slip through the cracks, leaving us with little time to respond. Efforts to deflect potential threats are underway, with ideas ranging from kinetic impactors to gravity tractors. These methods aim to nudge an asteroid off course, preventing a collision. But these solutions are still in their infancy, and their success depends on early detection. The harsh truth is that while we're making progress, we're not yet fully prepared for a cosmic strike. The risk of an asteroid or comet impact is a humbling reminder of our vulnerability in the universe. It's not a question of if, but when, another significant impact will occur. The question is whether we'll be ready when that day comes. For now, the skies above us hold both wonder and warning, a reminder that even in the vastness of space, our future hangs in the balance. The universe is stretching, growing larger every second. But what if this expansion, something we often take for granted, could one day tear everything apart? Enter the Big Rip, a cosmic event that sounds like something out of a science fiction movie, but is rooted in real astrophysics. Imagine a force so powerful that it doesn't just pull galaxies apart, it shreds stars, planets, and even the very atoms that make up matter. Over billions of years, the universe's expansion could accelerate to such an extreme that nothing, not even the smallest particles, would remain intact. This isn't just a dramatic idea, it's a genuine possibility based on our understanding of dark energy, the mysterious force driving the universe's expansion. If dark energy behaves in a certain way, it could overpower gravity, electromagnetism, and even the strong nuclear forces that hold atoms together. The result: A universe that literally unravels at the seams. While this scenario is so far in the future that it's hard to even comprehend, it serves as a stark reminder of how fragile our cosmic home truly is. What makes the Big Rip so fascinating and terrifying is its inevitability if certain conditions are met. It's not a question of if the universe will expand, it's already doing that, but how fast and how far that expansion will go. And while it might feel like a distant concern, it forces us to confront the idea that even the most fundamental forces of nature can hold the seeds of destruction. The Big Rip doesn't just threaten galaxies or stars, it threatens the very fabric of existence itself. Deep in the cosmos, where the remnants of dead stars linger, there exists a phenomenon so cataclysmic that it can ripple across the fabric of space-time itself. Neutron stars, the ultra-dense cores left behind after a supernova explosion, are already fascinating in their own right. But when two of these stellar remnants collide, the event is nothing short of astronomical chaos. These collisions are not just spectacular cosmic fireworks, they're also incredibly dangerous, capable of reshaping entire regions of space. When neutron stars merge, they unleash a cascade of violent phenomena. First, there are gravitational waves, ripples in space-time that propagate outward, detectable by observatories here on Earth. These waves carry the echoes of the collision, offering scientists a glimpse into the extreme physics at play. But that's just the beginning. The merger also triggers a gamma-ray burst, one of the most energetic explosions in the universe. These bursts are so intense that, if pointed in our direction, they could strip away Earth's ozone layer, leaving us vulnerable to harmful solar radiation. Yet, even amid this destruction, neutron star collisions play a crucial role in the cosmic ecosystem. They're responsible for creating some of the heaviest elements in the universe, like gold and platinum. That ring on your finger or the circuitry in your phone, those materials likely owe their existence to such a collision billions of years ago. But while these events are essential for the creation of rare elements, they also pose a significant threat. The immense radiation released during a collision could sterilize nearby planets, wiping out any potential life forms in its path. The real danger lies in proximity. If a neutron star collision were to occur within our galaxy, the effects could be devastating. Even from thousands of light years away, the radiation could disrupt our atmosphere and potentially trigger mass extinctions. It's a sobering reminder that the universe, for all its beauty, is also a place of unimaginable power and unpredictability. Neutron star collisions are a testament to the duality of cosmic events, both creators and destroyers, shaping the universe in ways we're only beginning to understand. Now think about this: a star so dense, a single teaspoon of its material would weigh billions of tons. That's a magnetar, a neutron star with a magnetic field so intense it defies imagination. These cosmic powerhouses are capable of unleashing starquakes, violent tremors on their surfaces that send shockwaves rippling through space. But the real danger lies in their ability to release bursts of X-rays and gamma rays, some of the most energetic forms of radiation in the universe. If a magnetar were to erupt within a few thousand light years of Earth, the consequences could be catastrophic. The energy released could strip away our planet's ozone layer, exposing all life on the surface to harmful ultraviolet radiation from the sun. Crops could fail, ecosystems could collapse, and the very fabric of life as we know it could be at risk. And here's the unsettling part: magnetars are unpredictable. Unlike other cosmic threats, we can't easily predict when or where these bursts might occur. What makes magnetars even more fascinating and terrifying is their sheer power. Their magnetic fields are millions of times stronger than anything we've ever created on Earth. To put it into perspective, if a magnetar were halfway between the Earth and the Moon, it could erase the data from every credit card on the planet. These celestial objects are a stark reminder that size doesn't always determine danger. Even a relatively small object, barely 20 kilometers across, can wield enough power to reshape the fate of an entire planet. Magnetars teach us an important lesson about the universe. It's a place of extremes where even the most unassuming phenomena can hold unimaginable power. And as we continue to explore the cosmos, we're constantly reminded that understanding these threats is just as important as marveling at their beauty. Picture our Milky Way, a vast spiral of stars, gas, and planets gliding peacefully through the cosmos. But this serenity is deceptive. In roughly 4 billion years, our galaxy will collide with its nearest neighbor, the Andromeda Galaxy. This isn't science fiction, it's a cosmic inevitability, a slow-motion dance that will reshape the night sky as we know it. Yet, while the collision itself might sound catastrophic, the real intrigue lies in the transformative chaos it could unleash. Galactic collisions are not simply crashes in the traditional sense. Instead, they're more like mergers where gravity weaves the two galaxies together into a single, larger structure. During this process, the immense gravitational forces at play can trigger bursts of star formation, lighting up the cosmos with newborn stars, but this creative energy comes at a cost. Planetary systems, including our own, could be flung out of their stable orbits, sent hurtling into the void, or even ejected entirely into the cold expanse of intergalactic space. What's fascinating is that while stars themselves rarely collide, space is just too vast. The gravitational disruptions could be profound. Imagine entire solar systems being pulled apart, their planets scattered like marbles across the universe. And yet, amid this chaos, there's a strange beauty. The collision could give rise to a brand new galaxy, often called Milkomda, a hybrid of the Milky Way and Andromeda. This new galactic structure might become a bustling hub of stellar activity, teeming with stars and planets born from the remnants of the collision. While 4 billion years is an unimaginably long time for us on a cosmic scale, it's just a blink. The Milky Way and Andromeda are already hurtling toward each other at speeds of over 100 kilometers per second. And when they finally meet, the collision will unfold over hundreds of millions of years, a slow but unstoppable force of nature. It's a reminder that even the most stable structures in the universe are subject to change, and that the cosmos is a place of both creation and destruction, often happening in the same breath. Picture a universe where the very fabric of space is being stretched beyond recognition, where galaxies are torn apart and even atoms are ripped asunder. This isn't science fiction, it's a very real possibility tied to the mysterious forces of dark matter and dark energy. Together, these unseen entities make up around 95% of the universe, yet they remain some of the greatest enigmas in modern science. Dark matter, with its invisible gravitational influence, acts like cosmic glue holding galaxies together. Without it, the stars we see at night would scatter into the void. But dark energy is even more elusive. It's the force driving the universe to expand faster and faster, pushing galaxies apart as if space itself is being inflated. What makes dark energy particularly unsettling is its potential to grow stronger over time. If that happens, the universe could face a catastrophic fate known as the Big Rip. In this scenario, the expansion of space becomes so extreme that it overcomes even the strongest forces binding matter together. Galaxies would be torn apart, stars and planets ripped to shreds, and eventually even atoms would be pulled apart. The universe would end not with a bang, but with a silent, unstoppable unraveling. The truly unnerving part, we don't fully understand what dark energy is or how it behaves. It could remain constant or it could intensify unpredictably. This uncertainty makes it one of the most profound threats to the future of the cosmos. As we peer deeper into the universe, the mystery of dark matter and dark energy reminds us just how much we have yet to uncover and how fragile the cosmic balance might really be. Imagine a single microscopic bubble forming in the fabric of space itself, a bubble so powerful it could unravel the very laws of physics as we know them. This is the concept of vacuum decay, a phenomenon rooted in the strange and unpredictable world of quantum physics. At its core, vacuum decay suggests that the universe might not be in its most stable state. Instead, it could be resting in a false vacuum, a precarious balance that could one day tip into a true vacuum, setting off a catastrophic chain reaction. If such an event were to occur, a bubble of true vacuum would begin to expand at the speed of light, rewriting the fundamental constants of nature in its wake. Gravity, electromagnetism, even the forces holding atoms together, everything we rely on to exist, could cease to function as we know them. The universe we inhabit would be transformed into something utterly alien, and life as we know it would be impossible. Now, you might be wondering, how likely is this to actually happen? The truth is, the probability of vacuum decay is incredibly low. Scientists estimate that if the universe were unstable in this way, it likely would have already decayed billions of years ago. But the sheer scale of the consequences, the complete annihilation of reality as we understand it, makes this one of the most terrifying possibilities in all of physics. It's a reminder of just how fragile the cosmic order might be, and how much we still have to learn about the true nature of existence. What's fascinating is that vacuum decay isn't just a doomsday scenario, it's also a window into the deeper mysteries of the universe. It forces us to confront questions about the stability of space-time, the nature of quantum fields, and the ultimate fate of everything around us. While the odds may be slim, the mere possibility of such an event challenges us to think bigger, to explore further, and to appreciate the delicate balance that allows our universe to exist in the first place. As we gaze out into the cosmos, it's easy to focus on the wonders it holds, but there's an invisible danger lurking in the void: cosmic rays. These high-energy particles, hurtling through space at nearly the speed of light, are born from some of the most violent events in the universe, like supernovas and black hole eruptions. While Earth's atmosphere acts as a shield, absorbing most of these particles before they reach us, the story changes when we leave the safety of our planet. For astronauts and even passengers on high-altitude flights, cosmic rays pose a real and growing threat. The danger lies in their ability to penetrate human tissue, damaging DNA and increasing the risk of cancer over time. Imagine your body as a delicate machine and cosmic rays as tiny, high-speed bullets that can disrupt its inner workings. For astronauts on long missions, like those to Mars or beyond, this isn't just a theoretical risk, it's a critical challenge that could shape the future of space exploration. Without the protective blanket of Earth's atmosphere, prolonged exposure to these particles could lead to serious health consequences, forcing us to rethink how we design spacecraft and protect those who venture into the stars. This isn't just a problem for astronauts, though. Even here on Earth, cosmic rays play a subtle but significant role. At high altitudes where the atmosphere thins, frequent flyers and airline crews are exposed to higher levels of these particles. While the risk is lower than in space, it's a reminder that cosmic rays are an ever-present force, influencing life on our planet in ways we're only beginning to understand. As humanity sets its sights on deeper space exploration, the threat of cosmic rays becomes impossible to ignore. New technologies like advanced shielding materials and even artificial magnetic fields are being developed to counter this invisible hazard. But the question remains, can we outsmart the very forces that shape the universe? The answer will redefine not just how we explore space, but how we survive in it. Imagine a star, not just any star, but one hurtling through the void of space at speeds so extreme it could cross entire galaxies in just a few million years. These are hypervelocity stars, cosmic outcasts flung from their homes by the immense gravitational forces of supermassive black holes. Now, picture what might happen if one of these rogue stars came too close to our own solar system. The consequences could be catastrophic. Hypervelocity stars don't just travel fast, they carry with them enough gravitational influence to wreak havoc. As one passes nearby, its gravity could tug on the delicate balance of our solar system. Planets, including Earth, might be pulled slightly off course, altering their orbits. Even a small shift could destabilize the entire system. But the real danger lies in what happens to the smaller objects in our cosmic neighborhood. The Oort cloud, a vast shell of icy bodies at the edge of our solar system, is home to countless comets. A hypervelocity star's gravitational pull could send these comets spiraling inward, creating a deadly barrage aimed directly at Earth. The result, a potential mass extinction event, similar to the one that wiped out the dinosaurs 65 million years ago. What makes hypervelocity stars so unnerving is their unpredictability. Unlike asteroids or comets, which we can track and predict with some accuracy, these stars move so fast and come from such great distances that we might not see one coming until it's too late. Their paths are wild and chaotic, shaped by the immense forces that launched them into the void. While the odds of a hypervelocity star passing close to Earth are incredibly low, the sheer scale of the universe means it's not impossible. And in the vast cosmic dance where stars are born, die, and are flung across the galaxies, even the rarest events can have profound consequences. It's a reminder of how fragile our place in the universe truly is, and how much we still have to learn about the forces that shape it. Quasars are some of the most luminous objects in the universe, and yet their brilliance hides a destructive potential that could reshape the fate of entire star systems. These cosmic powerhouses are the blazing cores of distant galaxies, fueled by supermassive black holes that devour matter at an astonishing rate. As material spirals into these black holes, it heats up to unimaginable temperatures, releasing torrents of energy in the form of intense radiation. This radiation is so powerful that it can outshine entire galaxies, making quasars visible across billions of light years. But what makes them truly awe-inspiring also makes them incredibly dangerous. Imagine a quasar forming within our own galaxy. The energy it emits would be catastrophic. Its radiation could strip away the atmospheres of planets, sterilize surfaces, and obliterate any chance of life within its reach. Even planets orbiting stars far from the quasar's epicenter wouldn't be safe. The sheer scale of destruction is hard to fathom. Entire star systems could be rendered lifeless in a cosmic blink. And while the odds of a quasar forming in the Milky Way are low, the possibility serves as a stark reminder of how fragile our existence is in the grand scheme of the universe. What's truly humbling is the sheer energy output of these phenomena. A single quasar can emit more energy in 1 second than our Sun will produce in its entire lifetime. That kind of power isn't just destructive, it's transformative. It shapes galaxies, drives star formation, and even influences the evolution of the universe itself. Yet, for all their destructive potential, quasars are also a testament to the incredible forces at work in the cosmos. They remind us that the universe is as beautiful as it is dangerous, a place where creation and destruction are often two sides of the same coin. White dwarfs, the quiet remnants of stars like our Sun, might seem harmless at first glance, but don't let their stillness fool you. When these dense stellar cores accumulate too much mass, often by siphoning material from a nearby companion star, they can reach a tipping point, triggering one of the most violent events in the universe, a Type Ia supernova. The sheer brilliance of these explosions is almost impossible to grasp. In an instant, a single white dwarf can outshine an entire galaxy, releasing energy equivalent to 10 billion suns. What makes these events particularly perilous is their unpredictability. Unlike massive stars that signal their demise with visible signs, white dwarfs can explode without much warning. And while the universe is vast, the effects of such an explosion could ripple across light years. If a white dwarf supernova occurred within a certain range of Earth, say within a few dozen light years, the intense radiation could strip away our planet's ozone layer, leaving life exposed to deadly ultraviolet rays from the sun. The result: catastrophic damage to ecosystems, agricultural collapse, and a threat to the survival of countless species, including our own. But here's the twist: white dwarf supernova aren't just destructive. They're also cosmic recyclers. These explosions scatter heavy elements like iron and nickel into space, seeding the universe with the building blocks of planets and even life itself. So while they pose a grave danger, they're also a reminder of the delicate balance between creation and destruction in the cosmos. The good news: the likelihood of a nearby white dwarf supernova is incredibly low. Astronomers estimate that such an event might occur within a threatening distance of Earth only once every few 100 million years. Still, the potential consequences are so severe that scientists keep a close eye on nearby white dwarfs, monitoring their behavior for any signs of instability. After all, in the vast theater of the universe, even the quietest actors can steal the show in the most dramatic way. Picture this: a vast, shadowy expanse stretching across the cosmos, filled with tiny particles of dust and gas, so dense that it can blot out entire stars. These are interstellar dust clouds, and while they might seem like just another beautiful feature of the universe, they hold a hidden danger. If one of these clouds were to drift into our solar system, it could have profound effects on our planet. Sunlight, the lifeblood of Earth, could be significantly dimmed, leading to a dramatic drop in temperatures. Over time, this could plunge our world into a temporary ice age, disrupting ecosystems, agriculture, and even human civilization. Interstellar dust clouds are not just random collections of debris, they are remnants of ancient stars, supernovae, and other cosmic events. These clouds can span light years, and while they are often the birthplaces of new stars, their sheer density can also act as a barrier, blocking the light from distant suns. If a particularly dense cloud were to pass through our solar system, it wouldn't just obscure the stars we see at night, it could reduce the amount of sunlight reaching Earth by a measurable amount. Even a small reduction in solar radiation could trigger cascading effects, altering weather patterns and potentially leading to a global cooling event. What makes this scenario so unsettling is its subtlety. Unlike a sudden asteroid impact or a nearby supernova, the effects of an interstellar dust cloud would be gradual, creeping over decades or even centuries. By the time we notice the changes, it might already be too late to adapt fully. And while the likelihood of such an event is low, the consequences are significant enough to warrant attention. It's a reminder that the universe is not just a place of beauty and wonder. It's also a place of unpredictability, where even the quietest phenomena can reshape the future of a planet. Now, let's turn our attention to Pulsars, cosmic lighthouses that spin at breathtaking speeds. These neutron stars, born from the explosive deaths of massive stars, emit powerful beams of radiation as they rotate. While their rhythmic pulses make them fascinating to astronomers, their potential threat to Earth is anything but comforting. If a pulsar were to align its beam directly with our planet, the consequences could be catastrophic. The intense radiation could strip away parts of our atmosphere, exposing life on the surface to harmful cosmic rays and ultraviolet light, potentially disrupting ecosystems and threatening biodiversity. But the danger doesn't stop there. Pulsars are surrounded by some of the strongest magnetic fields in the universe, fields so powerful they could tear apart the delicate electronics of spacecraft or harm astronauts venturing too close. Even our most advanced shielding technologies might struggle to withstand the onslaught of such extreme conditions. And because pulsars rotate so quickly, their beams can sweep across vast distances in mere milliseconds, making them unpredictable and difficult to track. What makes pulsars particularly menacing is their unpredictability. Unlike other cosmic threats, which often give us some warning, pulsars can suddenly shift their alignment or increase their activity without notice. This erratic behavior means that, while the odds of a direct hit are low, the risk is always present. It's a reminder that even in the vastness of space, some phenomena remain beyond our control, posing a silent but ever-present danger to life as we know it. Among the universe's most spectacular and destructive phenomena, Kilonovae stand out as both awe-inspiring and deeply unsettling. These cataclysmic explosions occur when two neutron stars, incredibly dense remnants of dead stars, spiral inward and collide. The result is a burst of energy so immense that it can outshine entire galaxies for a brief moment, scattering heavy elements like gold and platinum across the cosmos. But while these events might sound like something out of a science fiction epic, their potential impact on Earth is anything but fictional. The sheer power of a kilonova is difficult to overstate. When neutron stars collide, they release not only a blinding flash of light but also intense gamma radiation and gravitational waves. These gravitational waves ripple through space-time like ripples on a pond, carrying energy across vast distances. While the gravitational waves themselves are harmless, the accompanying gamma-ray burst could be catastrophic if it were to occur too close to Earth. Even at a distance of a few thousand light-years, such a burst could strip away our ozone layer, exposing the planet to harmful ultraviolet radiation from the Sun. But what makes Kilonovae particularly unique is their dual nature. On one hand, they are cosmic forges, creating the heavy elements that make up everything from the gold in your jewelry to the uranium in nuclear reactors. On the other hand, they are harbingers of destruction, capable of unleashing energy on a scale that dwarfs anything humanity has ever experienced. A nearby kilonova event, say within a few dozen light-years, would not only fry our atmosphere but also bathe the planet in a lethal dose of radiation, potentially triggering mass extinctions. Fortunately, kilonovae are incredibly rare. Scientists estimate that they occur only once every 100,000 years in a galaxy like the Milky Way. But rarity doesn't mean impossibility. The universe is vast and neutron star collisions are unpredictable. While the odds of a kilonova occurring close enough to Earth to cause harm are slim, the consequences would be so severe that it's worth considering. After all, the universe has a way of reminding us that even the most improbable events can have profound implications. What's fascinating is that kilonovae also serve as a reminder of the interconnectedness of the cosmos. The same forces that create the elements essential for life can also unleash destruction on an unimaginable scale. It's a delicate balance, one that underscores just how small and fragile our place in the universe truly is. Galactic superwinds might sound like something out of a science fiction novel, but these colossal outflows of gas and dust are very real, and they pose a threat that could reshape the future of our solar system. Picture this: vast streams of charged particles and debris, ejected at incredible speeds from galaxies millions of light-years away. These superwinds are often driven by two cosmic powerhouses, intense bursts of star formation, or the immense gravitational pull of supermassive black holes at the center of galaxies. When these forces come into play, they can launch material across intergalactic space, creating a kind of cosmic hurricane. Now, imagine one of these galactic superwinds passing through our solar system. The consequences would be nothing short of catastrophic. The sheer force of the wind could strip away Earth's protective atmosphere, leaving our planet exposed to the full brunt of cosmic radiation. Without that atmospheric shield, life as we know it would struggle to survive. The delicate balance that allows plants, animals, and humans to thrive would be disrupted, potentially leading to mass extinctions. Even our technology wouldn't be spared. Satellites, communication systems, and power grids could be overwhelmed by the influx of charged particles. What makes galactic superwinds particularly unsettling is their unpredictability. While we can track and monitor events like asteroid impacts or solar flares, these outflows originate from distant galaxies, making them harder to detect and study. Their immense scale and speed mean that by the time we might notice one heading our way, it could already be too late to prepare. This uncertainty adds another layer of risk to an already formidable cosmic threat. But here's the silver lining. The likelihood of a galactic superwind directly impacting our solar system is incredibly low. The vast distances between galaxies act as a buffer, reducing the chances of such an event occurring in our lifetime, or even within the lifespan of our species. Still, the mere possibility serves as a reminder of how interconnected our universe truly is. Forces from far beyond our galaxy can reach out and touch us, underscoring the fragility of our existence in the grand cosmic tapestry. What if something as small as a grain of sand could tear through our planet, leaving destruction in its wake? This isn't science fiction, it's the chilling possibility posed by micro-black holes. Unlike the massive black holes we often picture, these tiny cosmic anomalies could be as small as an atom yet pack a devastating punch. If they exist, their journey through Earth would be swift but catastrophic, releasing intense radiation and wreaking havoc on a local scale. Now, you might be wondering, how likely is it that we'd ever encounter one? The truth is, the odds are incredibly slim. Micro-black holes are purely theoretical at this point, and even if they do form, they'd likely evaporate almost instantly due to something called Hawking radiation. But here's the twist. If one did survive long enough to reach Earth, the effects would be unlike anything we've ever experienced. Imagine a microscopic object, smaller than a pinhead, passing through the planet and leaving behind a trail of destruction in its path. It wouldn't obliterate the entire world, but the localized damage, think earthquakes, volcanic activity, or bursts of deadly radiation, would be devastating. What makes micro-black holes particularly fascinating is their connection to some of the most cutting-edge theories in physics. Some scientists speculate they could form in high-energy environments, like those created in particle accelerators. While experiments like the Large Hadron Collider have ruled out the creation of dangerous black holes, the idea itself highlights just how much we still have to learn about the universe. So, while the risk of a micro-black hole encounter is almost zero, it's a reminder of the strange and unpredictable forces that exist in the cosmos. It's not just about the fear they might inspire. It's about understanding the delicate balance that keeps our planet safe from such extreme events. And as we continue to explore the mysteries of space, who knows what other surprises might be waiting for us out there? Now, let's turn our attention to one of the most mind-bending and potentially devastating cosmic phenomena: cosmic strings. These are not the kind of strings you'd find on a guitar or a piece of fabric. Instead, cosmic strings are theoretical, one-dimensional defects in spacetime itself, thought to have formed in the chaotic aftermath of the Big Bang. Imagine the universe as a vast, intricate tapestry. In that tapestry, cosmic strings would be like tiny, invisible threads woven into the very fabric of reality. But don't let their delicate description fool you. If one of these strings were to pass through Earth, the consequences would be anything but subtle. A cosmic string is so dense that a single inch of it could weigh more than Mount Everest. That's the kind of mass we're talking about. If one were to slice through our planet, it could trigger unimaginable destruction, ripping apart continents, warping space-time, and even altering the laws of physics as we know them. The gravitational effects alone could cause catastrophic earthquakes, tsunamis, and other natural disasters on a global scale, and that's not even the strangest part. Because cosmic strings are defects in space-time, they could theoretically distort time itself, creating bizarre phenomena like closed time loops or regions where time flows backward. Of course, cosmic strings remain purely theoretical for now. No direct evidence of their existence has ever been found, but the idea isn't just science fiction. It's rooted in some of the most advanced theories in physics, including string theory and quantum field theory. Scientists speculate that if cosmic strings do exist, they might be remnants of the universe's earliest moments, left over from when the cosmos underwent rapid expansion and cooling. Detecting one would be like finding a fossil from the birth of the universe itself. So, what are the odds of a cosmic string passing through Earth? Fortunately, they're astronomically low. These strings are thought to be incredibly rare, and even if they do exist, they're likely drifting in the vast emptiness of space, far from any inhabited planets. But the mere possibility of their existence reminds us just how strange and unpredictable the universe can be. It's a humbling thought that something as thin as a thread could hold the power to reshape reality itself. Among the countless stars dotting the night sky, red dwarfs might seem unassuming, small, dim, and often overlooked, but don't let their size fool you. These stars, the most common type in our galaxy, pack a surprising punch. Red dwarfs are notorious for their volatile nature, capable of unleashing stellar flares so intense they could dwarf those produced by our own sun. Imagine a sudden burst of energy, millions of times stronger than anything we've ever experienced, erupting from a star that appears calm and steady. The danger lies in the sheer power of these flares. If a red dwarf were to flare while positioned relatively close to Earth, our planet could be bombarded with a flood of high-energy radiation. This wouldn't just be a light show in the sky, it could disrupt our atmosphere, damage satellites, and even pose risks to life on the surface. The radiation could strip away parts of our protective ozone layer, leaving us exposed to harmful ultraviolet rays from the sun. And while red dwarfs are typically faint, their flares can briefly outshine their usual glow, making them unpredictable and dangerous. What makes red dwarfs particularly concerning is their longevity. Unlike larger stars that burn through their fuel quickly, these small stars are in it for the long haul. They can shine steadily for trillions of years, far longer than the current age of the universe. This means that even if a red dwarf isn't flaring now, it has billions of years to potentially unleash its fury. And because red dwarfs are so abundant, there's always a chance that one could drift closer to our solar system over time, bringing its volatile behavior within striking distance of Earth. The threat from red dwarfs isn't just a distant possibility, it's a reminder of how interconnected our planet is with the broader cosmos. While we might feel safe under the steady light of our sun, the universe is full of surprises, and red dwarfs are one of the most persistent and unpredictable ones. So the next time you gaze up at the stars, remember, even the smallest ones can hold the greatest dangers. Out in the vast emptiness between galaxies, where the darkness stretches endlessly, there's more than meets the eye. Intergalactic gas clouds, enormous and diffuse, drift silently through these voids, carrying within them the raw materials of creation: hydrogen, helium, and other elements. These clouds might seem harmless, even beautiful from a distance, but their quiet presence hides a potential for upheaval on a cosmic scale. Imagine one of these clouds spanning light years, drifting closer to the Milky Way. As it nears, the gravitational dance begins. The gas and dust within the cloud could compress under the pull of our galaxy, sparking the birth of countless new stars. On the surface, that might sound like a dazzling spectacle, a galaxy lighting up with fresh stellar fires. But the reality is far more chaotic. The sudden influx of new stars could destabilize existing planetary systems, throwing orbits into disarray and potentially hurling planets into the void of space. Even more concerning, this cosmic collision could disrupt the delicate balance that allows life to thrive. Planets that once enjoyed stable climates might find themselves exposed to intense radiation or pulled into erratic trajectories. For civilizations like ours, dependent on the stability of our solar system, such an event could spell disaster. Yet, it's not all doom and gloom. These clouds also represent the raw potential for renewal, showing how the universe constantly reshapes itself, even in ways that challenge our existence. The threat of intergalactic gas clouds is subtle, unfolding over millions of years, but their impact will be profound. They remind us that even in the quietest corners of the cosmos, forces are at work that could reshape everything we know. And while the chances of such an event happening in our lifetime are slim, it's a humbling reminder of just how dynamic and unpredictable the universe truly is. Imagine a universe that's not just expanding but stretching at a rate so fast it defies comprehension. This isn't science fiction. This is cosmic inflation, a phenomenon that happened just moments after the Big Bang. During this brief but explosive period, the universe expanded exponentially, growing from the size of a subatomic particle to something far larger than the observable universe we know today in just a fraction of a second. While this event is firmly in the past, scientists have raised an intriguing and somewhat unsettling question. Could cosmic inflation happen again? The idea isn't as far-fetched as it might sound. Some theories suggest that the conditions that triggered inflation billions of years ago could reoccur under certain circumstances. Think of it like a dormant volcano, calm for now, but with the potential to erupt again under the right conditions. If inflation were to restart, the consequences would be nothing short of transformative. Entire regions of space could be stretched beyond recognition, tearing apart galaxies, solar systems, and even the fabric of spacetime itself. The universe as we know it could be reshaped in ways that are almost impossible to predict. What makes this scenario particularly perilous is its unpredictability. Unlike other cosmic threats like asteroid impacts or supernova, inflation operates on a scale that's hard to measure or even imagine. If it were to happen again, it might not just affect a single star or planet, it could alter the entire universe. The laws of physics as we understand them could be rewritten, and the familiar structures of space and time might cease to exist in the way we know them. But here's the silver lining. The likelihood of this happening anytime soon is incredibly slim. Most scientists believe that the conditions needed for inflation to restart are either extremely rare or no longer possible in our universe's current state. Still, the mere possibility serves as a reminder of just how dynamic and unpredictable the cosmos can be. It's a humbling thought, isn't it? Even in the vastness of space, the universe holds secrets and dangers that we've only begun to uncover. What if some of the most dangerous objects in the universe have been hiding in plain sight all along? Primordial black holes are a fascinating and unsettling possibility, hypothetical black holes that didn't form from collapsing stars but instead emerged in the chaotic moments after the Big Bang. These ancient relics of the early universe could be smaller than a pinhead yet contain the mass of an entire planet. And here's the chilling part. If they exist, they might be drifting through our solar system right now, completely invisible yet capable of wreaking havoc. Unlike the black holes we're familiar with, which form from the collapse of massive stars, primordial black holes are thought to have been born from the extreme density fluctuations in the infant universe. Imagine the cosmos as a bubbling cauldron of energy, with pockets so dense that they collapsed under their own gravity, creating these tiny but incredibly massive objects. If they're out there, they could range in size from smaller than an atom to as large as a mountain, yet their gravitational pull would be immense. Now, picture one of these invisible wanderers passing near Earth or another planet in our solar system. Its gravity could tug at planetary orbits, subtly altering their paths over time. Even a small shift could have catastrophic consequences, throwing planets out of their stable orbits, disrupting the delicate balance that makes life possible here on Earth. And because primordial black holes are so small and dark, detecting them is nearly impossible with current technology. They're like cosmic ghosts, unseen but potentially devastating. But why should we care about something so hypothetical? Because if primordial black holes are real, they could explain some of the universe's biggest mysteries, like the nature of dark matter. Some scientists speculate that these ancient black holes might account for a significant portion of the invisible matter holding galaxies together. At the same time, their presence would remind us just how fragile our cosmic neighborhood really is. The idea of a tiny, invisible object with the power to destabilize entire planets is both awe-inspiring and deeply unsettling. A reminder that the universe is full of surprises, some of which we may never see coming. Galactic cannibalism might sound like something out of a science fiction movie, but it's a very real phenomenon happening across the cosmos. Picture this: vast galaxies, each containing billions of stars, locked in a gravitational tug of war. Over time, smaller galaxies are pulled into the embrace of larger ones, eventually being absorbed entirely. This process isn't just a cosmic spectacle, it has profound implications for the galaxies involved. As the smaller galaxy is consumed, its stars, gas, and dust are scattered, often triggering bursts of new star formation. While this might sound beautiful, it comes with a cost. Planetary systems within the smaller galaxy can be destabilized, their orbits disrupted as they're pulled into the chaos. Even the larger galaxy isn't left unscathed. Its structure can be altered, with new stars forming in unpredictable patterns. Our own Milky Way is no stranger to this process. In fact, it's currently absorbing smaller satellite galaxies like the Sagittarius dwarf galaxy. And in about 4.5 billion years, the Milky Way is set to collide with the Andromeda Galaxy, an event that will reshape both galaxies entirely. While this might seem like a distant concern, it's a reminder that even on the grandest scales, change is inevitable. What makes galactic cannibalism particularly fascinating is its dual nature. It's both destructive and creative. While it tears apart existing systems, it also fuels the birth of new stars and potentially new worlds. Yet, for civilizations like ours, it poses a long-term challenge. Over billions of years, the stability of our galactic neighborhood could be at risk, forcing future generations to adapt to a changing cosmos. So, while galactic cannibalism unfolds over timescales far beyond human comprehension, it's a powerful reminder of the dynamic and ever-evolving nature of the universe. And as we gaze at the night sky, it's humbling to think that even the stars above are part of a grand, ongoing dance of creation and destruction. While cosmic neutrinos may sound like something straight out of science fiction, these elusive particles are very real, and they're everywhere. Trillions of them pass through your body every second, completely unnoticed. These ghostly particles are nearly massless, traveling through the universe at speeds approaching the speed of light. But here's the catch: while they rarely interact with matter, their sheer energy makes them a potential wildcard in the cosmic game of chance. Imagine a particle so small and fast that it could zip through an entire planet without so much as a bump. That's the neutrino, but every so often one of these particles might collide with an atom. When that happens, especially with a high-energy neutrino, the results could be startling. Such a collision could release a burst of energy capable of damaging atomic structures. On a large enough scale, this could theoretically disrupt delicate systems, like the electronics we rely on or even biological processes. Now, before you start worrying about invisible particles wreaking havoc, it's worth noting that the odds of a catastrophic neutrino interaction are astronomically low. But in the vastness of the universe, even the rarest events can happen. Scientists have detected high-energy neutrinos originating from distant supernova and other cosmic phenomena, and while these particles pose no immediate threat, their existence reminds us of the unpredictable nature of the cosmos. What makes neutrinos particularly fascinating is their duality. They're both harmless and potentially hazardous. They're a reminder that even the most subtle forces in the universe can carry hidden risks. As we continue to study these particles, we gain a deeper understanding of the delicate balance that keeps our world safe and the rare events that could one day tip the scales. Now, let's venture into the realm of stellar collisions, a phenomenon that sounds like something straight out of science fiction, but is very much a part of the universe's chaotic dance. Picture this: two massive stars, each burning with unimaginable energy, hurtling toward one another in a cosmic game of chance. While these events are exceedingly rare, their potential consequences are nothing short of catastrophic. In dense star clusters, where stars are packed tightly together like commuters on a crowded train, the likelihood of such collisions increases. But even in the vast emptiness of space, the unthinkable can happen. If two stars were to collide anywhere near our solar system, the aftermath would be nothing short of apocalyptic. The sheer force of the explosion would unleash a torrent of radiation, powerful enough to strip away Earth's protective ozone layer and bathe our planet in deadly cosmic rays. The resulting shockwaves could disrupt the delicate balance of our solar system, potentially altering the orbits of planets or even flinging some out into the void of interstellar space. And while the odds of such an event occurring near us are astronomically low, the sheer scale of destruction makes it a threat worth considering. But why should we care about something so rare? It's not just about the immediate danger. Stellar collisions are a reminder of the universe's raw power and unpredictability. These events shape the cosmos, forging new elements and seeding the galaxy with the building blocks of future stars and planets. In a way, they're a testament to the cycle of creation and destruction that defines our universe. Yet, they also serve as a humbling reminder of our fragile place in the grand scheme of things, a tiny blue dot in a sea of unimaginable forces. While most cosmic threats originate within our own solar system, there's another kind of danger lurking in the vast expanse of interstellar space objects from other star systems. Take, for example, Oumuamua, the first interstellar object ever detected as it zipped through our solar system in 2017. Its unusual shape and mysterious acceleration sparked endless speculation, from comets to alien probes. Then there's Borisov, another interstellar visitor, which appeared just 2 years later. These objects are like cosmic postcards from distant stars, but they also remind us of a sobering truth. Not all interstellar travelers are harmless. The real concern lies in the unknown. Oumuamua and Borisov were relatively small, passing through without incident. But what if a much larger object, something the size of a small moon or even a dwarf planet, entered our solar system on a collision course with Earth? Unlike asteroids or comets from our own system, which we can track and predict with some accuracy, interstellar objects arrive unannounced, often traveling at incredible speeds. Their trajectories are harder to calculate, and their compositions are a mystery until they're close enough to study. This unpredictability makes them a uniquely dangerous threat. Imagine a scenario where an interstellar object traveling at tens of thousands of miles per hour enters our solar system with little warning. By the time we detect it, we might have only months or even weeks to prepare. The sheer speed and mass of such an object could deliver catastrophic energy on impact, dwarfing even the asteroid that wiped out the dinosaurs. And because these objects come from so far away, we have no way of knowing when or where the next one might appear. It's a cosmic game of chance, and Earth is always in the crosshairs. The good news, we're not entirely defenseless. Advances in telescope technology and space surveillance are improving our ability to spot these objects earlier. Missions like the Vera C. Rubin Observatory, set to begin operations in the next few years, will scan the skies with unprecedented detail, potentially giving us more time to respond to any incoming threats. Still, the challenge remains daunting. Interstellar objects remind us that the universe is vast, unpredictable, and full of surprises, some of which could reshape our future in an instant. The cosmic microwave background, often referred to as the CMB, is like a cosmic fingerprint left over from the earliest moments of our universe. This faint glow, permeating the entirety of space, is a snapshot of the universe just 380,000 years after the Big Bang. It's a relic of a time when the cosmos was a seething soup of energy and particles, before stars, galaxies, or even atoms as we know them existed. But what if this ancient afterglow, this echo of creation, began to change? Variations in the cosmic microwave background's temperature might seem subtle, but they hold profound implications. These tiny fluctuations, measured in mere millionths of a degree, are already responsible for the large-scale structure of the universe. Galaxies, clusters, and cosmic voids all owe their existence to these initial irregularities. However, if these variations were to increase even slightly, it could indicate a deeper, more unsettling shift in the fabric of reality. Imagine the CMB as a cosmic heartbeat, steady and predictable. Now, what if that heartbeat began to quicken or slow? A significant change in its temperature patterns could suggest that the universe is evolving in ways we don't yet understand, perhaps even destabilizing. This wouldn't be an immediate threat, of course. The timescales involved are vast, spanning billions of years. But over the long term, such changes could alter the very rules that govern the cosmos, from the behavior of dark energy to the expansion rate of the universe itself. What's truly fascinating and unsettling is how little we know about the forces that could drive such a shift. Is it possible that dark energy, the mysterious force accelerating the universe's expansion, could interact with the CMB in unexpected ways? Or could there be some deeper, undiscovered physics at play, waiting to rewrite our understanding of reality? While these questions remain unanswered, one thing is clear: the cosmic microwave background isn't just a window into the past, it's a barometer for the future. Monitoring its subtle whispers could be our best chance to anticipate and understand the universe's next great transformation. Quantum fluctuations might sound like something out of science fiction, but they're very real, and they happen all around us even if we can't see them. These tiny, unpredictable shifts in energy occur at the smallest scales imaginable in the fabric of space itself. Most of the time, they're harmless, little more than ripples in the cosmic pond. But under extremely rare and specific conditions, these fluctuations could become something far more dangerous. Imagine, for a moment, a fluctuation so intense that it creates a tiny black hole. While the chances of this happening are astronomically low, the implications are staggering. Such a black hole could, in theory, grow larger by consuming matter around it, potentially leading to catastrophic consequences for anything nearby. What makes quantum fluctuations so unsettling is their unpredictability. Unlike other cosmic events, which often follow observable patterns or cycles, these fluctuations are entirely random. They're a reminder that even the vacuum of space isn't truly empty, it's a seething, bubbling sea of potential energy. And while the likelihood of a fluctuation forming something as destructive as a black hole is incredibly slim, the sheer scale of the universe means it's not entirely impossible. Some scientists speculate that if such an event were to occur, It could even alter the structure of spacetime itself, creating ripples that disrupt the very fabric of reality. Of course, the odds of this happening are so low that it's not something we need to lose sleep over, but it's fascinating and a little humbling to think about how even the tiniest, most fleeting changes in energy could have such profound implications. It's a reminder that the universe is full of mysteries, some of which we're only beginning to understand. And while quantum fluctuations might not pose an immediate threat, they're a powerful example of how even the smallest events in the cosmos can carry the potential for enormous impact. Galactic jets are one of the most awe-inspiring yet terrifying phenomena in the universe. These immense streams of particles, often stretching thousands of light years into space, are launched from the cores of active galaxies. At the heart of these galaxies lies a supermassive black hole, a cosmic engine of unimaginable power. As matter spirals into the black hole, it doesn't just vanish, some of it gets ejected at nearly the speed of light in the form of these jets. Now, while they're undeniably fascinating to observe from a safe distance, their potential to cause destruction is what makes them a serious concern. If a galactic jet were to align directly with Earth, it could unleash a torrent of high-energy radiation unlike anything our planet has experienced. These jets are packed with particles like electrons and protons, accelerated to extreme speeds, and they emit gamma rays and X-rays, some of the most energetic forms of radiation known. Even a relatively brief exposure to such intense radiation could strip away Earth's ozone layer, leaving us vulnerable to the sun's ultraviolet rays. The consequences would be catastrophic, disrupting ecosystems, threatening life on land and in the oceans, and potentially triggering mass extinctions. What's truly unsettling is that this isn't just science fiction. There are galaxies out there with jets that could, in theory, be pointing our way. While the odds of one hitting Earth are astronomically low, the sheer scale of the universe means it's not impossible. The closest known active galaxy with jets, Centaurus A, is about 13 million light-years away, far enough to keep us safe for now, but a reminder of the unpredictable nature of the cosmos. What makes galactic jets particularly intriguing is their dual role in the universe. On one hand, they're agents of destruction, capable of sterilizing entire regions of space. On the other, they play a crucial part in shaping galaxies, influencing star formation, and redistributing energy across vast distances. It's a reminder that even the most dangerous cosmic events are part of the intricate balance that defines our universe. So while we may never face the direct impact of a galactic jet, understanding them helps us appreciate both the fragility and resilience of life in the cosmos. Stars are often seen as steadfast beacons in the night sky, unchanging and eternal. But the truth is they're far from static. Over time, stars gradually lose mass through processes like stellar wind streams of charged particles that flow outward into space. While this might sound like a slow and harmless process, it can have dramatic consequences, especially if it happens rapidly or close to home. Imagine a nearby star shedding a significant portion of its mass in a short period. This sudden loss could destabilize the delicate gravitational balance that keeps planets in their orbits, potentially flinging them into chaotic trajectories. In the worst-case scenario, one of these rogue planets could be sent hurtling toward Earth, posing a catastrophic threat. What makes stellar mass loss particularly concerning is its subtlety. Unlike explosive events like supernova, this process unfolds quietly over long periods, making it harder to detect and predict. Yet, its potential to reshape entire planetary systems makes it a cosmic danger we can't afford to overlook. While the odds of such an event happening in our immediate vicinity are slim, the sheer scale of the universe means we must consider even the most distant possibilities when thinking about the future of our planet. Picture the universe as a vast, intricate web with galaxies and clusters forming the threads. but between these threads lie enormous, almost empty regions known as cosmic voids. These voids are not just empty spaces, they're colossal, stretching hundreds of millions of light years across, and they play a surprising role in the structure of the cosmos. While they may seem like quiet, uneventful expanses, the truth is far more intriguing. If a cosmic void were to collapse, it could unleash forces capable of reshaping the universe as we know it. So, what exactly happens during a void collapse? Imagine these voids as the universe's negative spaces, regions where the density of matter is incredibly low. Normally, they exist in a delicate balance, held open by the interplay of dark energy and gravity. But if that balance were disrupted, perhaps by a sudden shift in dark energy or a buildup of matter at the void's edges, the void could begin to collapse inward. This process wouldn't be slow or gentle. As the void implodes, it could generate shock waves that ripple through the cosmos, triggering the formation of new structures like galaxy clusters while tearing apart existing ones. The implications of such an event are staggering. A collapsing void could send galaxies hurtling in new directions, altering their trajectories and potentially scattering stars into uncharted regions of space. On a larger scale, it could even influence the evolution of the universe itself, accelerating the expansion of some regions while causing others to contract. And while this might sound like a distant theoretical threat, it's a reminder of just how dynamic and unpredictable the universe can be. What makes cosmic voids particularly fascinating is their role as cosmic laboratories. They allow us to study the effects of extreme conditions like ultra-low density environments on the fabric of space-time. By observing these voids, scientists can gain insights into the nature of dark energy, dark matter, and the forces that govern the universe's expansion. Yet, they also serve as a humbling reminder. Even the emptiest regions of space hold the potential for profound and far-reaching consequences. So, while a cosmic void collapse might not be an immediate concern, it underscores the delicate balance that holds our universe together. It's a testament to the fact that even in the emptiest corners of space, the seeds of transformation are always present, waiting for the right conditions to unleash their power. The universe is a breathtaking tapestry of wonders, but woven into its beauty are threads of unimaginable danger. From the silent approach of rogue black holes to the blinding fury of gamma-ray bursts, these cosmic events remind us just how fragile our existence truly is. Yet, knowledge is our greatest ally. By studying these threats, we arm ourselves with the tools to anticipate, prepare, and even innovate in the face of the unknown. Every discovery brings us closer to understanding not only the universe but also our place within it. So as we gaze at the stars, let's marvel at their splendor while staying mindful of the risks they hold. What do you think about these cosmic dangers? Could humanity one day find a way to shield itself from the universe's most extreme threats? Let's keep the conversation going in the comments below. And if you're as fascinated by the cosmos as we are, hit that subscribe button for more journeys into the mysteries of space. Until next time, keep looking up.